Some properties of electrons in an atom. Now, when we describe electrons in an atom, we want to describe very accurately where they are in relationship to the nucleus and where they are with relationship to other electrons. Properties of electrons you're already familiar with are that electrons have mass and they have a charge. We're talking about the movement, the location, other properties of an electron in an atom right here. The second principal quantum number is what's called the orbital quantum number. And a way to describe, an easy speak way to talk about the orbital quantum number is the track of that orbital's movement. The first quantum number talked about the distance from the nucleus. This quantum number talks about the shape of the track. Now, the letters that correspond to the orbitals are what's more important here, but I'll match it up with the numbers too. So if it has a second quantum number of 0, we call it a letter S, and the S is what's more important right here. If it has a 1, we call it a P. If it has a 2, we call it a D. And this gives us the track or the shape of the path. I like that phrasing better. Shape of the path that electron can take in. Now, let's talk about what that shape looks like. For an S, for an electron that is in an S orbital, it can take on a spherical path around the nucleus. So I'll try to draw a little reflection window here to give this thing 3D character. Now, to get an idea of the perspective here, we are looking at the S orbital, and the nucleus is inside this S orbital. I'm going to put that in a different color. Right there. Okay? I haven't drawn any. If there are, at this point, there could be other electrons inside. There could be other electrons outside, but I'm just drawing this S orbital, and I'm putting the dot for the nucleus. You'll rarely see that dot for the nucleus right there. Now, a p orbital looks like this. It looks like two balloons. Let me make that larger. It looks like two balloons tied end to end, or a dumbbell. Now, this orbital path or shape, the electrons are confined to this shape right here. The distance from the nucleus could be different, but they're confined to this shape right here. The nucleus inside of this p orbital will be right there, what is called the node, or where those balloons are tied together right here. So an electron in a p orbital is meant to be on the sides right there. D orbitals, they have a generic shape for a d orbital is this. It's getting a little more complicated. This then the nucleus is right at the center point right here. In Gen Chem, we don't talk about d orbitals too much, but I do want to draw a picture of one, just get an idea how we have a sphere, a p, an S or a spherical orbital, a p or a dumbbell orbital, and then we have these d orbitals that look like clovers, and they get more complicated right there. The first quantum number talks about the distance an electron is from the nucleus, and the second one gives a shape of the path. Let's tie those two together. A 1s versus a 3s electron. The 1 and the 3, they are the principal quantum numbers. And on the periodic table, the 1 and the 3 are checked out right there. That means that the 1 is closer to the nucleus than the 3. The S is the shape of the path that electron takes. So a 1s orbital would look like that. and the nucleus is in the center there, that purple dot. A 3s orbital would look like this, again with the nucleus in the center. The first number tells us the distance, the average distance from the nucleus. The second principal quantum number, the S, tells us the average shape or the path right there. Where S's and P's are what we're going to use mostly. This horizontal trend on the periodic table, if each box tells you about an electron, this tells you that the electrons are getting further away from the nucleus. These first two rows tell you about the shape of the path that that electron can take, being an S shape. Again, the periodic table is designed around electrons. And that's a dirty little secret about chemistry. We're interested in how far electrons are away from the nucleus, what type of shape that electron's path is in. Hope this helps. Thank you.